Hello, today we are going to look at solving square root and other radical equations. So a little bit different than the rationals we've been practicing the last few days, but a radical equation is going to be an equation that has a variable in a radicand, which is essentially just saying your square root or your cube root, or a variable with a rational exponent. So a rational exponent would be an exponent that is a fraction. So if the radical has an index of 2, that means it is a square root equation. So the index is the number that goes inside this little root right here. With the square root, we usually don't write the 2, but we have anything bigger like a cube root or a fourth root, you will have that little number in what we call the index right there. And then we also will have our rational exponents. So that's going to be if you have a fraction for your exponent, what to do with that. So I just want to remind you guys that when you have these rational exponents, hopefully you remember doing this last year, the top number in the fraction represents the power and the bottom number represents the root. So I could write x to the power of 1/2 as a radical using 1 as my power, so this would be like x to the power of 1, and then if it's a 2, that means it's a square root. So these would be the same thing, just written in a different format. So we're going to be running into kind of both scenarios, if it's written as a fraction, a rational exponent, or if we have a radical. So when we are solving equations like this that have these radicals in them, you're going to solve them in the similar way as you would any normal equation where you're trying to isolate x, and you'll do that by doing the opposite operations of what you find inside your equation. But sometimes when you're going through these steps, they can introduce those extraneous solutions that we've talked about before, which means a solution that actually doesn't solve your equation. So if you plug it back in, it doesn't actually work. So we do want to be checking our answers to make sure that our solutions actually work. So let's try some. I'm gonna zoom in a little bit. Okay, so on this first one, I'm solving for x. So again, I want to isolate it, but I need to make sure to go through my steps the correct way. Right now I can't get into anything inside the square root while this 5 is here. So to get rid of a -5, we need to add 5 to each side. And so then those cancel, and I'm left with the square root of 4x plus 1 equal to 5. And now the square root is isolated, and I can't get to the inside of the square root until the square root is gone. So we need to get rid of that square root by doing the opposite, which would be squaring it. So square roots and squares cancel with each other, and that 4x plus 1 can just come out by itself. But if I square my left side, in order to keep my equation equal, I need to square the right side as well. So 5 times 5 is 25, and then now we just have a simple two-step equation. So first we're going to minus the 1 from each side, and that leaves me with 4x is equal to 24. And then to get rid of that 4, we will divide by 4. And so we get x is equal to 6. And again, you do want to check, because sometimes when you're going through these steps, you might get a solution that actually doesn't solve the equation. So to do your check, you're just going to plug 6 in for the x. So I'm going to have the square root of 4 times 6 plus 1, and then minus 5. We're checking to see, does this equal 0? We want it to equal 0 on this side. So if I simplify this, I get 4 times 6 is 24. So 24 plus 1 is the square root of 25. Well, square root of 25 is 5, so 5 minus 5 equals 0. So we do get 0 equals 0. So it's a true statement. That means x equals 6 is a true solution, and we get to keep that answer. If it wasn't a true solution, we would have gotten some other number equal to 0, which would have been a false statement, and so we would have said, oh, it doesn't work, and we would have thrown that answer out, which can happen. Okay, let's try another one. So on this one, we have 3 times the square root of x plus 3 equals 15. Again, we're trying to isolate that x and get it alone. So we have this 3 and this 3 to get rid of. Make sure you're doing the order in the correct way. So first we have to get rid of this plus 3 by subtracting. So do your add or subtract step first. Then we get 3 times the square root of x equals 12. Now we can get rid of the 3 before we do the square root. So to get rid of this times by 3, we are going to divide by 3. So we get the square root of x equals, and then now to get rid of the square root, we will square both sides so that that square root and square cancel, and we get x equals 4 squared, which is 16. And if we do a quick check, I'm not going to write it out, I'm just going to do it in my head. We get 3 times the square root of 16. Well, the square root of 16 is 4. So 3 times 4 is 12. 12 plus 3 is 15, so it works. Okay, so you can do those checks in your head really quick, but make sure to always check. Okay, let's try another one. So we have square root of 2x plus 3 minus 7 equals 0. So notice this minus 7 is not inside the square root, so we need to get rid of that first by adding it over. So that those cancel, and I'm left with the square root of 2x plus 3 equals 7. But now the square root is isolated and I can't get to the inside part until I get rid of it. So we get rid of that square root by squaring it, but I need to do that on both sides so that I get 2x plus 3, since those cancel. And then 7 squared is 49. So now to get the x alone, the next step would get rid of this plus 3 by subtracting 3. I'm running out of space. So that gives us 2x equals 46. Now we get rid of the 2 by dividing by 2. And 46 divided by 2 is 23. And if we hurry and just check that, if I plug 23 in for x, I get 2 times 23, which is 46. 46 plus 3 is 49. The square root of 49 is 7. 7 minus 7 is 0. So that one is good too. Okay, so those are ones that have radicals in them, but I want to look at some that also have our little fraction rational exponents. So to solve an equation that has a rational exponent, we need to get rid of that fraction exponent by taking each side of our equation to the opposite fraction, which is what we call the reciprocal fraction. So if my fraction exponent, my rational exponent is m over n, I'm going to raise it to the reciprocal power. So we're doing like a double power here, but we want to do the opposite. So if n is in the denominator, it's going to go into the top, and the numerator is going to go into the bottom. That way they can cancel with each other. But if I do that to one side, remember I have to do that to both sides. So let's try one of these. See, we have this little rational exponent here. We're trying to solve for x. We still need to do our steps the correct way. So right now with this equation, I can't get right to my reciprocal power because this 2 is out front. So we want to isolate the power before we can get rid of it. So first we need to get rid of this 2 by dividing by 2 so that that cancels. And now I have the x plus 3 to the 2/3 power. And then 8 divided by 2 is 4. So now that our power is isolated, we can get rid of it by taking it to another power. That's the reciprocal. So I'm going to flip this upside down and do the power of 3/2. That way the 2's cancel with each other, the 3's cancel with each other, and we just have the x plus 3 by itself now. But if I do that to the left side, I also need to do it to the right side. So I need to do this to the power of 3/2. So like I said at the beginning, if you remember, the top number represents your power, and the bottom number represents your root. So for this one, we have a square root of a 4 taken to a power of 3. So I can rewrite this as the square root of 4 for my 2 there, and then raised to the power of 3. You can also flip and do the 3 first and then the root. So you can also do 4 cubed first and then the square root. It doesn't matter the order, they're equivalent, but sometimes one is easier than the other. So for example, in this case, since 4 is a perfect square, it would make sense to actually take the square root first and then cube it, just because it makes my number smaller. Rather than if I do 4 cubed first, I'm going to get 4 times 4 times 4, which is 64, and then have to take the square root of it, which also still works. But usually if I can make my number smaller first, I like to do that. But now we can figure out what this is by doing the square root of 4, which is 2, and 2 cubed is 2 times 2 times 2, which is 8. So we get 8 as our answer. And then now I just have one more step to solve my equation. So I just have to subtract the 3 over, and we get x is equal to 5. And that would be your answer. Okay, let's try some more. So on this one, again, we have a number out in front, so I need to get rid of that 3 first by dividing by 3. And those cancel, and I have x minus 2 to the power of 3/4 is equal to 24 divided by 3, which is 8. And then now we can get rid of that power of 3/4 by doing the reciprocal power. So the reciprocal would be 4/3 here. But I'm also going to have to do. So these reciprocal powers will cancel, the 3/4 and the 4/3, and we're left with the x minus 2. And then here we have 8 to the 4/3. So I have a power of 4 and a root of 3, so a cube root on this one. The nice thing for us is 8 is actually a perfect cube. It's 2 times 2 times 2. So I'm going to do the cube root of 8 first, and then the power of 4. So remember, the power of 4 goes here, cube root there. So the nice thing is cube root of 8 is 2. And then we can do 2 to the power of 4, which is 2 times 2 times 2 times 2, which is 16. Okay, and then now we have x minus 2. So all we have to do is add that 2 over, and we get x is equal to 18. And that would be your answer. Okay, and let's do another one. So on this one, again, we need to get the exponent part alone. So we need to get rid of this minus 2 first by adding 2 to each side. So we have x plus 1 to the 3/2 power equals 27. So now to get rid of that power of 3/2, we're going to do a power of 2/3, the opposite of it, so that those cancel. But then I also need to do this to the power of 2/3. So now I have x plus 1 on the left, and then 27 to the power of 2/3 on the right. So remember, this was your power, so this is saying like 27 squared, and then a root of 3, so a cube root. Lucky for us again, 27 is a perfect cube. So if I take the cube root of 27 first, and then square it, the cube root of 27 is 3. So then I have 3 squared, which is 9. So then my last step is just to get rid of that plus 1 by subtracting 1. So those cancel, and I get x equals 8. That's my answer. And if you need to, you can use your calculator to do these root parts if you don't have them memorized. So I'll show you how to type those in really quick. So say you don't know what this is, you can use your calculator and just type in 27 and do the power, and then just type in your fraction, so 2/3, and it will give you the same answer. So you can use your calculator, but I also like you guys to use your head a little bit and kind of think through it. Sometimes that's actually faster than trying to type it in. Okay, let's look at some more. So like I said before, sometimes you can get those extraneous solutions. So far all the ones we've looked at haven't had an extraneous solution, so I want to look at some that do, just so you can see that they do show up. So it is important that we check all of our answers just to make sure. Like I've noticed in the past, I'll have students do their homework and they do all their work right, and they put their answer in to their assignment, and it marks them wrong and they don't know what they did. And that's because they didn't check their answer. So their solution might have worked as they were solving, but it doesn't actually work if you plug it back in. So always check. But on this one, we have the square root of 5x minus 1 plus 3 is equal to x. Notice on this one, we also have 2 x's here. Don't be freaked out by that. This x is already nice and pretty and isolated, so we're just going to ignore this one. So whenever you have two x's show up, you are going to focus on the x that's inside the square root. We're not going to worry about this guy right now. So pretend that this is just a number or something. We still want to get this x out of the square root. So to do that, the first thing I would need to do is get rid of this plus 3 by subtracting 3 from each side, which leaves me with the square root of 5x minus 1. Those cancel, but then I have x minus 3 over here. So now, again, we're still just focusing on this x. Don't worry about this one. We need to get rid of the square root by squaring, so that square root and the square cancel, and we get our 5x minus 1 by itself. But if I square this, I need to square my right side. This is considered like a group. We need to square this entire group together. Remember, when we square a binomial, we don't just do x squared and 3 squared. Sometimes I have students who just want to distribute that square through and say you have x squared minus 9. That's not what this means. This is saying to do x minus 3 times itself. So we need to do x minus 3 times x minus 3 and FOIL it. So if we FOIL this, we get x times x, which is x squared. Then x times negative 3 is a negative 3x. But then I also get another negative 3x. So if I add those, that's a total of a negative 6x. I'm just going to combine those right now. And then negative 3 times negative 3 will turn to a positive 9. Okay, so notice we also have an x squared in this one. So far, we haven't run into any x squareds. Whenever you need to solve an equation with x squareds in it, the only way you can do that is first you need to get 0 on one side. So I'm going to write that out. We want to get 0 on one side. So that's going to be your first step. So right now we have this 5x minus 1 over here. Let's move all of that over to this side. So to get rid of the 5x, I'm going to subtract 5x. And to get rid of the minus 1, we're going to add 1. I'm just going to do it all together. So that both of these cancel, and we just get 0 on one side like we're looking for. And then if we simplify all this, we have our x squared, and then negative 6x subtract 5x is a negative 11x, and then 9 plus 1 is 10. So now when you have 0 on one side and you have an x squared, an x, and a number, we have this nice trinomial here. The way you're going to solve it is you need to factor. So our next step is to factor it. So let's think, we do have a nice trinomial, that's a good thing. We can just think what multiplies to be 10 but adds to be negative 11. So our factors for that, and I like to do my little table with the little x's. We have what multiplies to be 10 but adds to be negative 11. Well, 10 times 1 is 10, and 10 plus 1 is 11, but we want it to be a negative 11, so we want to change both of those. So that negative 10 minus 1 is a negative 11. So negative 10 and negative 1 are going to be what goes inside our binomials. So we have x minus 10, x minus 1. So now once we have it factored, the way we solve it is to take each of those, and we want to set them equal to 0. And then solve from there. So the shortcut is you essentially just switch your sign, right? Because if I want to get rid of this minus 10, I'm going to add 10. So I get x equals a positive 10. If we add the 1 over, we get x equals a positive 1. So those are our solutions. But remember, some of these can be extraneous, and I will give you a little tip that usually if you have two answers, there's probably a pretty good chance one of them's extraneous and it doesn't actually work. So definitely check your answers when you have two of them. So let's plug them in really quick and do our check. See if I can fit it in this little space right here. If I plug 10 in for x, remember I have two x's, I need to plug it in for both. I'm going to get 5 times 10 minus 1 plus 3 equals x again, so I need another 10 right there. So we need this side to equal 10. So 5 times 10 is 50. 50 subtract 1 is 49. Well, the square root of 49 is 7. 7 plus 3 equals 10. So we get 10 equals 10. So this one works. So we get to keep this answer. This is a good answer. Let's check the 1 though. If I plug 1 in, I get 5 times 1 minus 1 plus 3 has to equal x again, which is another 1. So we plugged 1 in to both spots here. So 5 times 1 is 5. 5 subtract 1 is 4. The square root of 4 is 2. 2 plus 3 does not equal 1. This is saying 5 equals 1. That's not a true statement. That's an extraneous solution. When I plug 1 in, it doesn't actually work to solve my initial equation. So that's where we throw that answer out. So that's why it's so important to check, especially on ones where you have 2 answers like this. The chances of having an extraneous one goes up. So always check. Again, like I was saying, I'll have students do a problem like this and they go and type their homework answer in as 10 and 1 and they're like, I did it right, it's saying I'm wrong. That's because one of their answers is extraneous. So make sure to check your work so you can catch those extraneous ones. Let's try another one. Okay, so on this one, again, we have 2 x's. Don't worry about the x that is not in the square root. This one's good. We're only going to focus on this guy right here. We want to get him out of that square root. So right now, the only thing we have is the square root. I can't do anything with the 3 or the 5 until that square root is gone. So we are going to square it first, which means I also need to square this side. That square root and the square cancel, and I get that negative 3x minus 5 out by itself. But then I have x plus 3 squared. Remember, we can't just distribute that square through. I need to do x plus 3 times x plus 3 and FOIL it. So I get x times x is x squared. X times 3 is 3x. But then I get another 3x. So 3x plus 3x is 6x total. And then 3 times 3 is 9. Really similar to what we just did up here, except that was a minus and now we have pluses. So again, just like the problem we just did, we have x squareds here. Whenever you have an x squared to solve, you need to first get 0 on one side and then factor it. So let's move both of these over to our other side. Let's add the 3x over, add the 5 over, so that we get 0 on that left side. And then on the right side, we have x squared plus 9x plus 14. And then we want to factor. So think of what multiplies to be 14 but adds to be 9, and that will be 7 and 2. So 7 times 2 is 14. 7 plus 2 is 9. So we get 0 will equal x plus 7 times x plus 2. So our solutions, again, the shortcut is just to switch the sign. If this is x plus 7, then our solution will be x equals negative 7. And if this is x plus 2, our solution will be x equals negative 2. But again, we want to check. So let's check by plugging negative 7 in. So I'm going to plug negative 7 in for 2 x's. Remember, we had 2 of them. So negative 3 times negative 7 minus 5. And then that needs to equal x plus 3. So negative 7 plus 3. So if we simplify, negative 3 times negative 7 is a positive 21. 21 minus 5 is 16. The square root of 16 is 4. But then here we have negative 7 plus 3, which is negative 4. So our signs here don't match up. They're both 4s, but one's a positive and one's a negative. And I know technically when you take the square root, you should have a plus or minus 4 here, right? But that's only half of our solution. So since we have a plus or minus, a positive 4 and a negative 4, but this is only a negative 4, it's not good enough. So we're actually going to throw this one out. It's not a good solution. Let's check negative 2, because sometimes you might have both that don't work. So negative 3 times negative 2 minus 5 needs to equal x plus 3, which will be a negative 2 plus 3. So we plugged a negative 2 in for both x's. Simplifying, negative 3 times negative 2 is positive 6. 6 minus 5 is 1. Well, the square root of 1 is just 1. And then negative 2 plus 3 is 1. So that one is good. We're going to keep that one. Okay. Let's look at this one right here. This time we have one of the rational exponents, so we'll have to get rid of that. But before we can do that, we need to get rid of this minus 1 by adding 1 to each side. So we have x plus 3 to the 1/2 power equals x plus 1. And then now to get rid of that fraction exponent, we're going to do the reciprocal, which is 2 over 1, or just 2 really. So essentially we're just squaring it. So we get x plus 3 back. But if I do this to the power of 2 over 1, I'm just going to put 2. That's like we're squaring it. So I need to do x plus 1 times x plus 1. So again, 2 over 1 is just the same as 2. So we need to FOIL this really quick. So we get x times x is x squared. Then x times 1 is 1x plus another 1x. So 1 plus 1 is 2x's. And then 1 times 1 is 1. So just like our last problems, we do have that x squared, so we need to get x on one, or 0 on one side. So let's minus that x over, minus the 3 over, and we get 0 equals x squared. 2x minus x is 1x, and then 1 minus 3 is negative 2. So now on this one, we need to think what multiplies to be negative 2 and adds to be 1. So that would be 2 and negative 1. So 2 times negative 1 is negative 2. 2 subtract 1 is 1. So we get x plus 2, x minus 1 is our factors. But then when we get our solutions, we flip the sign. So we get x equals negative 2 and x equals positive 1. So if we plug these in, I'm just going to do a quick check because I don't have much space here. If I plug negative 2 in, I get negative 2 plus 3 is 1. The square root of 1 is just 1, and 1 minus 1 is 0. And so if I plug in negative 2 here, 0 does not equal negative 2. So this one doesn't work. If we plug in 1 here, 1 plus 3 is 4. Remember, a power of 1/2 is like a square root, so square root of 4 is 2. 2 minus 1 is 1. So that one does work, so we're going to keep this one. So again, usually when you have two answers, there's a really good chance one of them doesn't work. So always check to make sure. I know I didn't write that one out, but hopefully you followed along close enough. Okay. And then I want to do at least one more. Okay, let's look at what happens if you have something on both sides, either a square root or a rational exponent like this. Remember, a power of 1/2 is the same as doing a square root. So you can think of it either way. So I could write this as 2x to the power of 1/2 is the same as the square root of 2x. And then x plus 5 to the power of 1/2 is the same as the square root of x plus 5. So you could do it either way, however you want to think about it. If you like writing as a root more than a fraction exponent, go for it. But really you're doing the same thing. So when we want to get rid of this fraction exponent, you're just going to do the opposite. So the opposite of 1/2 would be 2 over 1, or just 2. But those cancel and you get the 2x back. And if I do that on this side, those cancel again and I just get x plus 5. So it's almost easier when you have one on both sides because they're just both going to cancel out. And so we just have x's here, so we're going to get our x's to one side. Let's minus the x over. And we get 2x subtract x is x equals 5. So that one was really easy. We just get x equals 5. But let's check and plug it in, make sure it works. So we had 2x to the power of 1/2. So I'm going to do 2 times 5 to the power of 1/2. Needs to equal 5 plus 5 to the power of 1/2. Well, 2 times 5 is 10 to the 1/2. And 5 plus 5 is 10 to the 1/2. So I'm actually not even going to worry about what the square root of 10 is. Remember, this is like the square root of 10 and the square root of 10. It's just a decimal point, but we know it's the same on both sides. So we're good. We don't need to actually look at what that decimal is because we know that they are equal. So this answer is good and we would keep it. So hopefully you guys feel okay with that process. If you have any questions, please don't hesitate to reach out to me. I'm here to help you. We can set up a Zoom if you need. But go ahead and get started on your homework and let me know if you have any questions. Hope you guys have a good day. See you later.